Your Linux servers aren't just running containers anymore, they're hosting invisible tenants that security teams can't even detect.
Wait, invisible tenants? Are you saying there's malware that's basically undetectable in cloud infrastructure right now?
VoidLink isn't just undetectable, it's designed to live in your cloud for years, learning, adapting, and every major cloud provider is vulnerable.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into VoidLink, the cloud-native malware framework weaponizing Linux infrastructure.
But first, let's cover today's top headlines.
There's a critical Node.js vulnerability affecting Datadog APM that platform teams need to know about. According to Datadog's security blog, this denial of service vulnerability could potentially impact application monitoring capabilities.
How widespread is this? Are we talking about all Node.js versions or specific ones?
The article focuses on mitigation strategies, which suggests it's serious enough that teams can't just wait for a patch. They're recommending immediate action for anyone running Node.js with Datadog APM.
That's going to be a fun Monday morning for a lot of teams. Speaking of production readiness, though, we've got some debtor news from the CNCF.
Absolutely. Dragonfly just graduated from the Cloud Native Computing Foundation. This cloud native image and file distribution system is now officially production ready, joining the ranks of Kubernetes and Prometheus.
I've seen Dragonfly solve some serious container image distribution bottlenecks. The fact that major organizations are already using it at scale really validates the graduation.
And for AWS users, there's an interesting update to VPC IPAM. Amazon just announced that IP policies now support RDS instances and application load balancers.
Finally! IP management for RDS has been such a manual process. This should help with compliance requirements too, right?
Exactly. Centralized IP allocation strategies mean fewer manual errors and better governance. Now, switching gears completely, there's a rather passionate blog post making rounds about GitHub Actions.
I hate GitHub Actions with a passion from xlii.space. That's quite the title. What's got them so fired up?
The author dives deep into specific pain points and limitations they've encountered using GitHub Actions for CI/CD. It's actually raising some valid concerns about the platform's architecture and debugging experience.
I'd love to hear if others in the platform engineering community share these frustrations. GitHub Actions has become so ubiquitous, but maybe we're all just living with these issues?
That covers today's headlines. Now let's get into our main story. So let's talk about something that should be keeping every platform engineer up at night. VoidLink, this new cloud-native malware framework Checkpoint Research just uncovered. And Alex, what's really unsettling here is that this isn't your typical malware that got retrofitted for the cloud. This thing was born in the cloud.
Born in the cloud? What do you mean by that exactly?
I mean, it's specifically designed to weaponize Linux infrastructure in cloud environments. It can detect whether it's running on AWS, GCP, or Azure, figure out if it's in a container or VM, and then adapt its behavior accordingly. We're talking about malware that understands cloud primitives as well as we do.
Okay, but we've seen cloud-aware malware before. What makes VoidLink different?
The sophistication level. This isn't some script kiddie operation. Checkpoint found over 30 different plugin modules. Each one serves a specific purpose: credential harvesting, lateral movement, container escape, you name it. But here's the kicker. It's not trying to ransomware your data or mine crypto. It's designed for long-term, persistent access.
So it's more like a sleeper agent than a smash and grab operation.
Exactly, and that's what makes it so dangerous for platform teams. We're already struggling with alert fatigue, trying to distinguish between legitimate developer activity and potential threats. Now we have malware that's specifically designed to look like legitimate cloud operations.
But surely there must be some indicators we can look for.
There are, but they're subtle. We're talking about things like unusual plugin loading patterns and processes, specific memory manipulation techniques, or containers making API calls they shouldn't need. The problem is, in a dynamic cloud environment with auto-scaling, CI/CD pipelines, and microservices, what even counts as normal anymore?
That's a good point. Our environments are so dynamic that establishing a baseline is already challenging.
Coming up, we'll dig into exactly how VoidLink pulls this off technically, what those 30-plus modules actually do, and why this represents a fundamental shift in how attackers are thinking about cloud infrastructure.
All right, so let's get into the technical weeds here. How does VoidLink actually work once it's in your environment?
So the architecture is fascinating in a terrifying way. At its core, VoidLink uses a modular plugin system. Think of it like a malicious version of kube control plugins or Terraform providers. The base implant is relatively small, about 2 megabytes, but it can dynamically load additional capabilities as needed.
So it's not carrying around a massive payload that might trigger detection.
Exactly. The base module handles core functions, process injection, memory manipulation, and the plugin loading mechanism. Then, based on what the attacker needs, they can load specific modules. Need to harvest AWS credentials? There's a module for that. Want to escape from a container? Different module. Need to clean up forensic evidence? Another module.
How does it handle the plugin loading without getting caught? I mean, most security tools would flag unusual library loads or process modifications.
This is where it gets clever. VoidLink uses a technique called reflective DLL injection on Linux. Instead of writing files to disk, which would trigger file integrity monitoring, it loads everything directly into memory. The modules are encrypted and only decrypted at runtime, making static analysis nearly impossible.
And I'm guessing it's not using standard dynamic linking that we could trace with tools like Strace or Ltrace?
Nope. It implements its own custom loader that bypasses the standard Linux dynamic linker entirely. Checkpoint found that it even hooks system calls at the kernel level to hide its activities from tools like PS, Netstat, or LSOF.
But kernel-level hooks should be detectable, right? We have tools for that.
In theory, yes, but VoidLink is smart about it. It uses a technique called DCOM, direct kernel object manipulation. Instead of hooking the system call table, which is what most rootkit detectors look for, it modifies kernel data structures directly. So your process might be running, but it's been unlinked from the process list that tools read.
That's actually pretty sophisticated. What about container environments? How does it operate there?
This is where it really shines, unfortunately. VoidLink can detect if it's running inside a container by checking for things like .dockerenv, cgroup paths, or specific environment variables. Once it knows it's containerized, it loads modules specifically designed for container escape.
What kind of escape techniques are we talking about?
Multiple vectors. It can exploit misconfigurations like containers running with privileged flags or excessive capabilities. It looks for writable proc paths, checks if the Docker socket is mounted inside the container, or tries to exploit kernel vulnerabilities for escape. But here's the really scary part. If it can't escape, it doesn't keep trying and risk detection.
It just waits?
It pivots strategy. Instead of escaping, it might focus on credential harvesting within the container, waiting for service account tokens, environment variables with secrets, or mounted config files. Remember, in Kubernetes environments, even a compromised pod can potentially access the API server or other services.
And with 30-plus modules, I'm guessing there's a lot more capability we haven't even touched on.
Oh, absolutely. There are modules for SSH key harvesting, modules that can intercept and modify network traffic, modules for persistence across reboots, even modules specifically for major cloud providers. The AWS module, for instance, can use the instance metadata service to grab temporary credentials and then use those to enumerate and access other resources in your account.
But the metadata service has protections now, like IMDS v2 requiring session tokens.
True, but VoidLink's modules are updated regularly. If IMDS v2 is enforced, it'll try other methods, looking for credentials in environment variables, config files, or even memory dumps of legitimate processes. It's like playing whack-a-mole, where the mole keeps learning your patterns.
What about the command and control infrastructure? How does it communicate without triggering network monitoring?
Another clever aspect, VoidLink supports multiple C2 channels, HTTPS, DNS tunneling, even steganography in legitimate traffic. It can use domain fronting techniques, hiding its traffic behind legitimate CDN services. In cloud environments, it might even abuse legitimate cloud services for C2, making traffic blend in with normal API calls.
So we could have this thing living in our infrastructure, slowly mapping out our entire environment, and we might never know.
That's the nightmare scenario. And with its modular nature, even if you detect and remove some components, others might remain dormant, waiting to reinfect the system. Stick around. We'll give you the exact checklist for defending against this threat and what platform teams need to do right now.
Okay, so given everything we've discussed, what can platform teams actually do to defend against VoidLink?
First, let's be clear, there's no silver bullet here, but there are concrete steps you can take. Start with runtime security. You need tools that can detect behavioral anomalies, not just known signatures. Solutions like Falco, Sysdig, or commercial equivalents that use eBPF to monitor system calls in real time.
But you mentioned VoidLink can detect these tools and dial back its activity.
Right, which is why you need defense in depth. Don't just deploy the tools, randomize their configurations. Use custom rules, not just the defaults. VoidLink might know how to evade standard Falco rules, but it can't adapt to custom policies it's never seen.
What about at the container and Kubernetes level?
Critical controls here. First, never run containers as root unless absolutely necessary. Use pod security standards or pod security policies to enforce this. Second, drop all unnecessary Linux capabilities. VoidLink needs certain capabilities for its advanced features. capsys ust ptrace for process injection, capsys us module for kernel manipulation. Drop these by default.
What about those escape techniques you mentioned?
Never mount the Docker socket inside containers. Ever. Use read-only root file systems where possible. And here's one people miss. Use seccomp profiles. The default Docker seccomp profile blocks about 44 syscalls, but you can go further. Create custom profiles that only allow the specific syscalls your app actually needs.
That sounds like it could break a lot of applications.
It requires testing, absolutely, but tools like Inspector Gadget can help you trace which syscalls your apps actually use. Start in monitoring mode, build your baseline, then enforce. Yes, it's work, but it's work that could prevent a catastrophic breach.
What about at the cloud provider level? You mentioned VoidLink has specific modules for AWS, GCP, and Azure.
IMDS v2 is mandatory, no exceptions. But go beyond that. Use VPC endpoints for cloud API access so you can monitor and control that traffic. Enable CloudTrail, Cloud Audit Logs, or Azure Activity Logs, and actually alert on anomalies. Look for unusual API calls, especially around credential enumeration or resource discovery.
But that generates a lot of noise.
Which is why you need smart filtering. Focus on high-risk API calls, anything touching IAM, attempts to disable logging, or calls from unusual source IPs. And here's a key point. Ship these logs to an immutable storage location immediately. VoidLink has modules for log tampering, but it can't modify logs that have already been shipped off-host.
What about detection? Are there specific indicators we should be looking for?
Yes. Look for processes with unusual memory patterns. Legitimate processes don't usually have executable memory regions without corresponding file mappings. Monitor for processes that are CPU idle but have active network connections. Check for discrepancies between /proc and what system tools report.
That sounds like it needs pretty sophisticated monitoring.
It does, which brings me to an important point. You might need to level up your security operations. Consider tools like OS Query for endpoint visibility or Velociraptor for incident response. These can query system state in ways that are harder for malware to hide from.
What about the human element? This seems like it requires a different mindset from traditional security.
Absolutely. Platform engineers need to think like attackers now. Run regular threat modeling exercises. Ask yourself, if I were an attacker with persistent access to this container, what could I do? Build your defenses based on those scenarios, not just compliance checkboxes.
Any specific recommendations for teams that might already be compromised?
If you suspect VoidLink or similar malware, don't just reboot or redeploy. These tools have persistence mechanisms. You need to do forensic analysis, understand the full scope of compromise, then rebuild from known good states, and assume credential compromise. Rotate everything.
This really changes how we need to think about cloud security, doesn't it?
It does. The old model of perimeter security is completely dead. When your infrastructure itself can be weaponized, when malware understands cloud APIs as well as your own developers, you need continuous verification, zero trust, and defense in depth. But here's the thing. The same automation and tooling that makes cloud powerful can be turned to defense. Use infrastructure as code to ensure consistent security configs. Use admission controllers to enforce policies. Make security part of your platform, not bolted on after.
So it's not all doom and gloom?
Not at all, but it requires evolution. Platform engineering isn't just about making developers productive anymore, it's about making them productively secure. And frameworks like VoidLink, they're the wake-up call that this evolution needs to happen now, not someday. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.